That's going to make it x squared minus 9x plus 19 is equal to 0. Should be able to easily identify the A, B, and C values. All right, leading coefficient, -9, and the 19, A, B, and C. All right, so then we apply the quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Pop in the appropriate values. Yeah.
I forgot if you said sorry, but are we gonna have to memorize that?
Yeah. All right, so we're looking at x is equal to negative the b value. I'll just use parentheses to replace the constants first. Then just plug it all in. All right, so negative b, -9, plus or minus -9 squared, minus 4 times 1 times 19, all over 2 times 1. Oh, it just snapped back. All right, clean it up. We got the 9 plus or minus something under the radical, if I can speak, all over 2. That thing under the radical we could just chuck into the calculator. I mean, you could also, just figure it out. But if you put it into the calculator using parentheses, it'll take care of the order of operations for you. All right, so we get a rad 45.
It's 19.9.
Oh, thank you. And there we are. All right, 5 is not a radical that we could break down, or at least radical 5 it isn't. So that would be it. Nothing else to do at this point. All right, but let's look at a case where you do have to break down the radical. All right, so looking at number 1, same deal. I'm going to add the 1 to both sides. Clean it up. Identify the A, B, and C values. And apply the quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. Yep. Already did that. All right, so -12. Let's go red here. -12 squared minus 4 times 6 times 1 over 2 times 6. All right. Plug the radicand into your calculator. And 120 is the result. That is something that can be broken down. So I'm going to take that off on the side, do a little side work. All right, so we're looking for a value, the largest perfect square value that will divide evenly into 120. We know one of those values will be 4, but we want to see if there's a better one. So if you don't remember, we go to the table, typing in x squared, start off around half the value of the radicand, and start working our way down. So you look at it and say, well, 49, does 49 go into 120? What about 36? What about 25? You know, that idea. So 120 divided by, well, 49 isn't going to work. But you might try like 36. That didn't work. You might try 25, but there's no reason why that would work. So you try 16. That didn't work. So it might just be the case that it's equal to 4, because 9 isn't going to work. And just as a refresher, if you lost this along the way, you can also type in 120, in this case 120, divided by y1, so alpha trace y1. And that'll give you the result of dividing 120 by any of the values in the y1 column. So you'll see that the only instance in which you get a whole number, aside from the trivial case of 1, would be the case of 4. So 4 and 30. Anything beyond that is going to give you a decimal. You know, except if you went all the way up to 120, but you know, those are the trivial cases. So 4, rad 4 and rad 30. So 2 radical 30. That replaces the rad 120. So 12 plus or minus 2 rad 30 over 12. But then we have to look to reduce the fraction. So you look at it and say, is there something I could do with the coefficients? So I have a 12, a 2, and then, you know, and the bottom is 12 also. All right. So each one of these numbers is even. They're all divisible by 2, so we could divide them all by 2. So 6 plus or minus 1 radical 30, which would just be radical 30, over 6. All right, and so that would be our final. All right. So what I'd like you to do for practice is the rest of 45 and 46, please. Because I think we already did 47. Okay, but identifying the A, B, and C values, first key step in this process. 3, -2, -9, A, B, C. All right. So again, the quadratic formula, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. There's a song. I will not be singing that for you, but there is a song for the quadratic formula, and folks in the past said that it was helpful in getting them to memorize it, which is great. So, I mean, I feel like I'm going to end up doing it, but maybe not now. Maybe I'll have a guest speaker come in and do it. So what I like to do, I mentioned this before, is instead of the B's, the A's, and C's, open set of parentheses. I think that's the best way to go about it. I mean, in my opinion. Because then you're not going to forget to put those parentheses in when you type it into the calculator. All right, so negative 2 plus or minus the square root of negative 2 squared minus 4 times 3 times negative 9 all over 2 times 3. All right, parts of it are very easy. The part that's not, you chuck right into the calculator. As long as you have those parentheses there, you're going to be in good shape. So open them up, negative 2, close them up, squared, minus 4 times 3 times negative 9. Close it up, enter, you get 112. All right, now that 112 is not as simple, clearly, as the 5 in the previous problem. So we have to break this down. So we do a little side work. All right, just kind of pull it off. I minimize it and it doesn't minimize. Pull it off on the side. So I'm going to take this, swing it on up over here. That 112, I'm going to break that down. Now, 112 has a 12 in it, so a good place to start would be, what are the factors of 12? Like 4, 12, things like that. But if you can't think of it, we have the calculator technique. And if you haven't taken the time to set up your calculator for this kind of thing, I recommend it. All right, so I'll just clear out what I have here. In the y equals menu, we're going to type in x squared. All right, x squared. That's going to give us a list of perfect square values. All right. So if I go into my table now, second graph, I now have a list in y1 of perfect squares. Wonderful. All right. But you'd have to manually check these. All right. So I would look for the value that's half of 112, or at least in the neighborhood of half. And then I'd start testing and say, okay, well, what's 112 divided by 49? 112 divided by 36? It could be a pain. So what we do in y equals, we go to y2 and we type in the radicand 112 divided by whatever we have in y1. Now you could just type in x squared if you want, but we could also just call up y1. All right, we do that by hitting alpha, trace. All right, alpha trace brings up a list of y values, y1 through y0. We want y1. Hit enter, and now in a new column, second graph, in a new column, we not only have the list of perfect square values, we have the result of taking our radicand and dividing it by those perfect square values. All right, so now we're only on the lookout for anything that's a whole number, all right, in the y2 column. Because 1 times 112, that'll give us 112. But that's the trivial case. That's not going to help us. All right, 4 times 28. I suspected 4 was a factor of 112. It is, but is it the best one? So I go down my list here. I see 16 also gives me a whole number in y2. 16 times 7. Now 7's a prime number. That can't be broken down any further. So that means that we found our winner, rad 16, rad 7. If you keep going down, just to be sure, you'll see that we're all out of whole number responses in y2, so we're good. All right. So this is our winner, 16 times 7. Yeah.
Whenever you do that, alpha trace, mine only goes to a graph.
Oh, you have an 83? TI 83? Yeah. So what you want to do, it's a little bit more complicated. You go into You know, you do your 112 divided by y1. Let me just do it. You're going to hit vars, the vars key right next to clear. Then you're going to hit the right arrow to y vars. Then select function, so enter, and then y1 will be there. No problem. All right, so we have our winner, the 16 and the 7. All right, rad 16 is 4. Rad 7 is rad 7. We can't do anything about that. All right. So this is going to substitute in for the rad 112. All right. So I'm looking at this now as a new expression, but an equivalent one, 2 plus or minus 4 rad 7 over 6. Now I want to look to see if I could simplify further. I would do that by taking whatever the coefficients are and seeing if there's a common factor that can be divided out. All right. They're all even, so my first suspicion is that the common factor would be 2. All right, but I look to see if I can get a better one, like 4. 4 will work for 4, but not for the 2 or 6. So it looks like 2 is my winner. What we do is we divide each term by 2. So 1 plus or minus 2 rad 7 over 3. All right. Now, if you have a hard time figuring out what the common factor is, we could use the GCD on the TI. All right, so again, math, go over to NUM, and run it down to option 9, GCD. We have 2, 4, and 6. You know, these are easy numbers, but, you know, you can run into cases where they're not quite so easy. So I would do, remember, GCD only works 2 terms at a time. So I would do the 2 and the 4, and then take that result and apply it to the next value, the 6. So math, NUM, option 9, 2 and 6. Whatever the GCD is out of all of these terms, that's the value you divide by. All right. Very quickly, I just wanted to show you on Desmos, because folks have asked about that. It's pretty straightforward. I made a Desmos calculator for you to have, but I wanted to show you from scratch where you would or how you would come up with it. So Desmos graph and calculator. So we want a table. So what I do is I hit the plus sign and select table. All right. It defaults to x1, y1. I don't want x1, y1. I want x. I mean, you can use whatever you want, but I want x and x squared.
What would you press to get the quadratic equation?
In here?
Yeah.
The quadratic equation. Well, so far I've pressed plus table.
Oh.
Yeah. So all I'm doing now is coming up with a list of perfect square factors. All right. So I would type in a set of values in my x column, like 1 to 10 is usually sufficient, but maybe I want to go further. The good thing about Desmos is even though it doesn't give you the raw list, initially you have to type it in. If you just hit enter a bunch of times, you'll get there. You know, like I want to go. Oh, look at that! I'm already up to 73. You know, so you get a good set of values, and then once you click out of there, it truncates it. It'll ask you if you want to show all the rows. Maybe you only need like a handful, like a little bit in the beginning, a little bit at the end. But then this is the key step. In the third column, so I click into my table, go to my third column, right arrow. I want whatever my radicand was divided by x squared. So if my radicand in this problem was 112, I would type in 112 divided by x squared. And now I have a list of factors just like we would in the table method. So by hitting second graph, we get this, same deal, all right? The benefit of Desmos is that instead of using 112, I could just come up with a placeholder value like A, for example. It'll tell me I did something wrong, but I didn't, you know, because I have to define what A is. So I'll say let A equal some constant value, 112. And you're like, oh, how's that any different? Well, now I have a slider, right? So if I want, I'm trying to remember, in the previous problem, I think it was number one, I think the radicand was like 120. So now I can manipulate it here using my slider and get out to 120. All right, now I have my raw list. All right, so I saved this for you with a couple of instructions, and I'll have this up on Schoology so that you have access to it. But it's nice to have these little resources because you look at something like 512. Like if the radicand's 512, you might say, okay, well, I'm pretty sure 4 is one of the factors. That's great. But is it the best one? I don't know. How do I know? Well, you start trying different possibilities. But that could take a while. All right. So Desmos and the TI can kind of streamline that for you. All right.